today I will show you the encryption mechanism, the cryptography kind of thing in cybersecurity. What happened in cryptography, like we have to send data from one end to another end, right? And for that we need to use an encryption method. Why we need encryption method? Because I need to make sure the data to whom I'm sharing with is the only person or are the only persons can view the data, and no other person can view the data or access the data. This is the main purpose of encryption. So the thing is, in computer world we have cryptography. We have two type of encryption algorithm, which is symmetric and asymmetric. Which is symmetric? Let me write down here, symmetric. My handwriting is not very good, so please bear with me. Symmetric means you have one secret key, right? And this secret key will be used to lock or unlock. In our computer world, encryption and decryption with the same secret key. It is only one key. Just imagine, in your computer, in your Windows, Mac, Linux, whatever it is, you have a lock screen. You need to give your password to open the computer. This is the secret key, like secret key. What happens if you enter this key to your computer? Now the computer will open. Okay, cool idea it is. Problem is here, if you share this secret key, to any person, maybe A, B, C, whoever is trying to log in or log into this computer, you cannot identify, right? This is the problem. Whoever has the secret key can log into your computer. Whoever has this key can enter your house. You have a house, and in that house there is a padlock. Whoever has the key, they can enter. You cannot identify, you cannot make sure who is the correct person, who is the not correct person, wrong person who entered into the building or not, right? This is the problem. So which affects the repudiation pillar of information security, which is very important. Repudiation. It affects the repudiation. It doesn't affect the confidentiality. It doesn't affect the availability. It doesn't affect the integrity. It affects the repudiation. Right. So symmetric is one type of algorithm, one type of encryption in cryptography. Another we have, which is asymmetric. Asymmetric. My handwriting is bad. Please bear with me. Asymmetric encryption. Asymmetric encryption we need to understand. It is little bit tricky, but very good for understanding. So why we use asymmetric encryption? Because it gives us confidentiality, integrity and availability, as well as repudiation. Availability I cannot say, depending on the server. Encryption doesn't give the availability. Generally encryption gives us the confidentiality kind of thing, and apart from confidentiality, it gives us repudiation, right? So where we are using this asymmetric encryption? Anytime we are transmitting data from one point to another point, we are using asymmetric encryption. Imagine just like a WhatsApp. In WhatsApp, we have what we have? End-to-end encryption. End-to-end encryption, right? So we are using this asymmetric encryption for WhatsApp, and I will show you how it works. For example, we have two different users. The first user is Louis, second user is Ankit, right? Louis want to send a message to Ankit. Before that, we need to understand few things here. So the message will be hello. This is a hello message, HELLO, hello. What is this? It is a plain text, because I can read this message, plain text. Now when this message will be encrypted, that time the value will be some gibberish value like X, Y, Z, 1, 2, 3. I cannot read from that message what is exactly within the message. It is called ciphertext, right? So whenever we are encrypting the message, it becomes the ciphertext. Okay, this is number 1 rule. Number 2 rules: every user, every sender, receiver within this communication has 2 keys. One is private key, another is public key. What is private key and what is public key? Let me show you here. Private key is the one which can only be available to the owner. Louis has a 2 key. Louis has 2 key. One is public, one is private. This key is, these 2 keys, first of all, these 2 keys are interrelated. Number 1. Similarly, Ankit has 2 keys, public and private. These 2 keys also related. Okay. So private key, this private key can only be available to the owner. No other in this world can have the same private key. That means Louis' private key will be with Louis forever, all over the internet, all over the world. Similarly, Ankit's private key will be with Ankit throughout the entire lifetime and throughout the entire scenario, and it will be only one throughout the world. If someone got Ankit's private key, that means Ankit's account got compromised. If someone got Louis' private key, then Louis' account got compromised. Okay. Now, how about the private key? Public key? How about the public key? Public key can be available to anyone. No one can do hacking kind of thing with this public key. If they get the private key, then they can possibly do some compromise of the account. Okay. Now, Louis sending message to the Ankit, right? Okay. Louis encrypt this message and send this to the Ankit. Very good. Message is hello message. Okay. In this case, what will happen? If Louis send this message to Ankit, anyone from internet, we are into the internet environment, can read this message, right? This is a problem for us because it breach the very important clause of confidentiality. Confidentiality breach without any encryption. Breach without encryption. Okay, I'm trying to make it easy for you, no worry. This is scenario 1. Scenario 1. Okay, now scenario 2. Same thing, Louis has a 2 key. Ankit, same, has 2 key. Pub, private, public, private. Now, Louis again send this message through internet to Ankit. This time, what Louis is doing, Louis encrypt this message. Earlier stage without encryption. Now they encrypt the message, hello message. Okay, and what Ankit will be getting, Ankit will be getting some value like X, Y, Z, 1, 2, 3, 4, this kind of encryption message. So Louis will encrypt this message with Ankit's public key. This public key. Louis encrypt with Ankit's public key. Why? Because private key is available with Ankit, and it is not possible for Louis to get the private key of Ankit, and public key is available throughout the world, and anyone can get the public key. So Louis will encrypt this message with Ankit's public key. Now send this message to Ankit. Ankit use its private key. Ankit use its private key to unlock the message. Unlock, you can say decrypt, right? Because those two keys are interrelated. I show you here. Where I showed you, here I show you. Okay, these two keys are interconnected. Louis encrypt this message with Ankit's public key. When the message reaches to Ankit, Ankit simply uses private key to decrypt the message and read the message. What things we achieve now? We achieve confidentiality. Confidentiality. Okay. In earlier stage, we did not get anything within the CIS triad. We did not get confidentiality, which is the ultimate purpose of encryption. We did not get anything. In the second stage, we get the confidentiality because it is encrypted by Ankit's public key, and Ankit is the one who can decrypt it because no other person can have this private key. Okay, simple idea. Ankit has two keys. One key is with Louis, one key is with Ankit. These two, simple idea. Okay, now we get the confidentiality. Very good. Now the problem is here, how Ankit know this message really came from Louis. That means repudiation is missing here. We need to understand the repudiation. So scenario 3, we will get the repudiation now. Same scenario, Louis, two key, public, private, Ankit, public, private. Okay. Now this time it will be little bit different because Louis is sending message to Ankit by using its own private key. Yes, its own. Louis use its own private key to encrypt. Okay, this message now reached to the Ankit. Now Ankit will simply use Louis public key to decrypt. Unlock. Okay. Now again understand, Louis send this message with encryption to Ankit with its own private key. So these two keys are interconnected. It reached to the Ankit. This time Ankit did not use its own public key, private key, anything. Simple thing, it decrypt the message with Louis public key. It is encrypted by private key of Louis. Now it is decrypted by public key of Louis. Simple thing. Now Ankit 100% sure that this message came from Ankit because it opened only by decrypting through public key of Louis. Now we achieve repudiation because Louis cannot deny that I did not send this message because Louis has its own private key here. Louis cannot deny I did not send. In earlier situation, see, Louis sent this message by using Ankit's public key, right? And Ankit decrypted this message by using its own private key. In this scenario, Louis sent this message by its own private key. Here we are not getting any repudiation, but here we are getting repudiation because it is encrypted by its own private key, and the private key is the one which can only be with the owner. See, can only be available to the owner. Louis have its own private key unless Louis account got compromised, right? So we are not going for exceptions. We assume that Louis has its own private key. Louis encrypt this message and send this to the Ankit. Now Ankit decrypt the message by using this public key to read the message. We achieve here repudiation. The question is here, whoever has Louis public key can decrypt this message, right? But if we combine these two, confidentiality and repudiation, we can achieve both of them, confidentiality and repudiation. This is simple asymmetric encryption, and this is called RSA algorithm. In the exam, if they give you a scenario and ask for find out the confidentiality, this is the right environment. You need to tell that for confidentiality, we need to get the public key of the receiver before encrypting the message, and the receiver will decrypt it through its own private key. If they ask you about repudiation, that time the best answer is the sender will send this message by encrypting this message with its own private key. Receiver will decrypt this message with sender's public key. In the exam, they may give you a scenario and they will ask you a potential good answer. For the confidentiality, scenario 2. For the repudiation, non-repudiation, scenario 3 will be the best answer, right? So if you have any question, please do let me know. I'll explain again. I know it's a little bit tricky, but still I'll explain. But do ask me if you have any question. We'll see you in another video.